Multiple choice question test practice for CS certificate level information technology. This episode covers the topics volatile and non-volatile storage, and it is from chapter 3 of the syllabus. The serial number of the question is 131 to 140 from chapter 3. First question. The primary use case of volatile storage in computer system is A. Backing up system configurations, B. Long-term data storage, C. Storing firmware for embedded systems, D. Execution of applications and processing data. The question is, what is the primary use case of volatile storage in computer system? And alternative options are number A. Backing up system configurations, B. Long-term data storage, C. Storing firmware for embedded systems, D. Execution of applications and processing data. The correct answer is D. Execution of applications and processing data is the primary use case of volatile storage in computer system. Next question 132. Volatile storage is the storage with high read-write speeds and permanent data retention, or storage that temporarily holds data and loses it when power is off, or storage specifically used for long-term data archiving, or storage that retains data even after power is turned off. We have to find out the volatile storage device among them. Storage with high read or write speeds and permanent data retention. Storage that temporarily holds data and loses it when power is off. Storage specifically used for long-term data archiving. Storage that retains data even after power is turned off. Since the volatile device cannot retain the data when the power is turned off, the option B is the correct answer. Storage that temporarily holds data and loses it when power is off. Next question. Which of the following is not a non-volatile storage type? Option A, SSD. Option B, HDD. Option C, DRAM. Option D, flash memory. It's a tricky question. We have to find out which one is not a non-volatile storage type. Option A, SSD. SSD is non-volatile. HDD also non-volatile. Flash memory is also non-volatile storage device, but DRAM is volatile storage. So the correct answer will be here DRAM. Dynamic random access memory is not a non-volatile storage type. DRAM is not a non-volatile storage type. It is volatile storage type, so the correct answer is C. Next question. The key advantage of volatile memory compared to non-volatile memory is A. Faster access and lower latency. Option B. Data retention without power. Option C. Ability to store larger data sets. Option D. Lower cost per bit of storage. The question is, which one is the key advantage of volatile memory compared to non-volatile memory? Option A, faster access and lower latency. Option B, data retention without power, ability to store larger data sets. Option D, lower cost per bit of storage. The correct answer is A. The key advantage of volatile memory is faster access and lower latency compared to non-volatile memory. Non-volatile memory technologies like NAND flash suffer from which of the following limitations? Option 1, high power consumption during idle state. Next option, limited write endurance. Another option is high latency for read operations. And last option is inability to perform sequential read operations. The question is, Non-volatile memory technologies like NAND flash suffer from which of the following limitations? Option A, high power consumption during idle states. Option B, limited write endurance. Option C, high latency for read operations. Option D, inability to perform sequential read operations. The correct answer is B, limited write endurance. It's a limitations for which non-volatile memory technologies like NAND flash suffers. Question. Which of the following is true about EEPROM compared to flash memory? Option A, EEPROM allows block level erasure only. Option B, EEPROM has higher density and lower cost than flash memory. Option C, EEPROM is a volatile memory type. Option D, EEPROM provides byte level access for read and write operations. The question is, which of the following is true about EEPROM compared to flash memory? Option A, EEPROM allows block level erasure only. EEPROM has higher density and lower cost than flash memory. EEPROM is a volatile memory type. EEPROM provides byte level access for read and write operations. The correct answer is option D. EEPROM provides byte level access for read and write operations. Now we shall try to know about EEPROM. According to Wikipedia, EEPROM or a square PROM, electrically erasable programmable read-only memory, is a type of non-volatile memory. It is used in computers, usually integrated in microcontrollers such as smart cards and remote keyless systems, or as a separate chip device to store relatively small amounts of data by allowing individual bytes to be erased and reprogrammed. Next question 137. Emerging memory technologies like MRAM and ReRAM are primarily designed to address what issue in non-volatile storage? Option A, high latency and endurance constraints. Option B, slow read speeds. Option C, poor performance at high temperatures. Option D, limited scalability in smaller geometries. The question is here, MRAM and DRAM are primarily designed to address some issues in non-volatile storage. We have to find out the issue which they can address among the all options given here. Option A, high latency and endurance constraints. Option B, slow read speeds. Option C, poor performance at high temperatures. Option D, limited scalability in smaller geometries. The correct answer is high latency and endurance constraints is an issue in non-volatile storage, and MRAM and ReRAM are primarily designed to address such issues. Now we try to know about MRAM and ReRAM. What is MRAM? According to Wikipedia, MRAM stand for magnetoresistive random access memory. It is a type of non-volatile random access memory which stores data in magnetic domains. And ReRAM stands for resistive random access memory. It is also called RAM. RAM is a type of non-volatile random access memory, computer memory that works by changing the resistance across a dielectric solid-state material, often offered to as a memory store. Question number 138. What is the role of volatile memory in computer systems? Option A, stores the bootloader permanently. Option B, provides backup power for non-volatile storage. Option C, acts as a high-speed buffer for faster processing. Option D, acts as a medium for archiving logs. What is the role of volatile memory? Option A, stores the bootloader permanently. Option B, provides backup power for non-volatile storage. Option C, acts as a high-speed buffer for faster processing. Option D, acts as a medium for archiving logs. The correct answer is C, acts as a high-speed buffer for faster processing. Volatile memory in computer systems usually act as a high-speed buffer for faster processing, and it is the role of volatile memory. 139. In the context of non-volatile storage, what does OL leveling refer to? Option A, preventing data loss during power outage. Option B, distributing write and erase operations across memory cells to extend the life of a device. Option C, distributing data evenly across memory cells. Optimizing sequential write speeds. The question is, what does OL leveling refer to in the context of non-volatile storage? That's been the definition or description of OL leveling we have to find out among these options. Option A, preventing data loss during power outages. Option B, distributing write and erase operations across memory cells to extend the life of a device. Option C, distributing data evenly across memory cells. Option D, optimizing sequential write speeds. The correct answer is B, distributing write and erase operations across memory cells to extend the life of a device. Question of this episode: which statement is correct regarding SRAM and RAM? A, SRAM is faster but consumes more power than RAM. B, both SRAM and RAM are non-volatile. Option C, SRAM is non-volatile and RAM is volatile. Option D, DRAM uses flip-flop circuits whereas RAM uses capacitors. We have to find out the statement which is correct regarding SRAM and RAM. Option A, SRAM is faster but consumes more power than RAM. Option B, both SRAM and DRAM are non-volatile. Option C, SRAM is non-volatile and DRAM is volatile. Option D, DRAM uses flip-flop circuits whereas SRAM uses capacitors. The correct answer is A, SRAM is faster but consumes more power than DRAM. That's the end of this episode. Thank you very much.